Okay, here we are doing SIG number 14, which is on the product quotient and advanced chain rule. It's just to make sure we know how to do product rule, quotient rule, and use a table of values to do derivatives. For the first one, we can see that these two things are being multiplied. So like we kind of have a choice. We could like multiply this out, like FOIL it, and then take the derivative. But the point here is that we're trying to know product rule, right? So the product rule is if I'm taking the derivative of some two functions that are being multiplied, it's u prime v plus v prime u, right? The derivative of the first times the second plus the derivative of the second times the first. So this one, u prime is going to be the derivative of this first piece. Maybe just do this in color here. The derivative of the first piece is going to be 5x to the fourth, and we're going to multiply that by the second piece, which is this, and then we're going to add that to the derivative of the second piece times the first piece, like that. Then this up here, the instruction does say simplify your answer as much as possible. So in this case, we can like distribute these in here and then combine like terms. So we're going to go ahead and do that, right? So this is going to give me 20x to the 8th plus 25x to the 4th plus, over here we're going to get 16x to the 8th plus 64x to the 3rd. And we can combine like terms. 20x to the 8 and 16x to the 8 are going to give me 36x to the 8 plus 25x to the 4th plus 64x to the 3rd. So that's as simple as that one gets. All right, for the next one, we have u and v. There's two functions here, and the derivative rule says that if I am taking the derivative of two functions being divided, two things that are divided, I have to do u prime v minus v prime u all over v squared, right? So the top is, the reason I like to write it this way is because the top of this is very similar to this except for that minus sign in the middle. All right, so here we go. U prime as the derivative of the top is going to be 20x to the 3rd plus 6x squared. And we're going to multiply that by v, which is 4x squared plus 5. And then we're going to subtract the derivative of the bottom, which is 8x, and that has to be multiplied by the top, which looks like that. And this is all over the bottom, the denominator, squared, right? So it's all over 4x squared plus 5. And this one does say simplify as much as possible, so we're going to want to distribute these things and combine like terms, right? So we're going to go ahead and do I don't know if that's worth our time to do that. So I might change the wording on this question, at least for this product rule one, where we don't simplify it. You know what? It's not that bad. Let's just do it. 20x times this is going to give us 80x to the 5th plus 100x to the 3rd, right? We're just distributing that in, and then we're going to distribute this in. That's going to give us plus 24x to the 4th plus 30x squared. And then, before we combine like terms there, let's go ahead and distribute this guy too. That's going to be negative 40x to the 5th minus 16x to the 4th minus 24x, and it's going to all be over 4x squared plus 5 squared. Don't worry about multiplying this out. That like rarely ever, like pretty much never, does anything for you. So we just need to find like terms down here. I have x to the 5th and 80x to the 5th and negative 40x to the 5th. That's going to simplify to 40x to the 5th. Right, I have 100x cubed Actually, let's not do that yet. Let's do the fourth powers first, since that's the next biggest exponent. 24x to the fourth minus 16x to the fourth is going to give us plus 8x to the fourth. And then the next one is the cubic, which is 100x cubed and 30x cubed. So that's going to be 130x cubed. Right, that came from that. And lastly, just the negative 24x is the only one that's left. And we'll just put that all over 4x squared plus 5 squared. All right, so that's going to be the simplest case there. For number 3, you're given this table of values, and you're given some different functions that are defined in different ways, and you want to find the derivative of that function evaluated at the different values, right? So for part 1, we're given h1 of x is f of x plus g of x. Find h prime of 1. So first we find h prime of x, which, because they're just being added, you can just do f prime of x plus g prime of x, right? In which case h prime of 1 is simply f prime of 1 plus g prime of 1, which f prime of 1, if you come over to the table, f prime of 1 is negative 1. So we would write negative 1 here, plus g prime of 1 is 1, right? So plus 1. And that would give us 0, right? So h prime of 1 is 0, and I should be putting like a little 1 on this h prime, right? Because this is the first part. H prime of 1 is 0 for that one. For part 2, we're given h2 of x is f of x times g of x. So h2, the derivative of that, please notice that this is a product, so you're going to have to use product rule. So the derivative is going to be f prime of x times g plus g prime of x times f. And then when we want to find the derivative at 3, we're basically just plugging in 3 into these everywhere there's an x, and finding these values on the table, right? F prime of 3, if we look over here, f prime of 3 is negative 1. So this is going to be negative 1 times g of 3 is 4, right? We found that here, plus g prime of 3. G prime of 3 is 0. It doesn't really matter what this is now because it's just going to be 0, but let's just find it anyway. F of 3 is 2, and so our answer here is going to be h prime of 2, sorry, h2 prime is negative 4. Alright, that's part 2. Let's do part 3 over here. Given h3 of x equals f of x over g of x, we want to find, oh, so I don't need to write that word. That's what we're given. We want to find h prime. So h prime, please recognize this is a quotient, so we're going to need to use quotient rule. That's going to be f prime of x times g of x minus g prime of x times f of x all over g of x squared, right? And then we just plug in these numbers, right? Let's just save some writing. We can go ahead and plug these in, right? I want to find h prime of, in this case, 4. So let's just write this. I want to find h prime of 4. So I'm going to write 4 everywhere in here, right? Just replace all those x's with 4s, and we're going to find that h prime of 4, f prime of 4 is negative 1. And just go put a bunch of parentheses here because we're just going to replace these guys with stuff. So, so f prime of 4 is negative 1, g of 4 is 2, g prime of 4 is negative 2, f of 4 is 1, and then on the bottom it's g of 4, and then we square that, so g of 4 is 2, that's going to be squared, And if we do all this, it's going to be negative 2 plus 2 over 4, which is 0, right? So part 3 is 0. Let's keep going with part 4. Do it right here. Part 4 says, well, this is our function. And we want to find the derivative, so it's going to be the derivative of part 4. You have to use chain rule here, right? Bring down the 2 times f of x times the derivative of the inside, which is f prime of x. And then again, we're just going to replace these with our numbers, which it wants us to evaluate it at 1. So we're going to place all our x's with 1s. And that will give us 2 times something, right? And so f of 1 is 4. From our chart up there, we can see f of 1 is 4, and f prime of 1 is negative 1. So we have the derivative at 4 is 2 times 4 times 1, which is negative 8. All right, that's part 4. And lastly, part 5. Our function in this case is f of g of x. And we're asked to find the derivative. This again is chain rule. We take the derivative of the outside. The inside stays the same. And then you multiply it by the derivative of the inside, right? And we're trying to find this evaluated at 4. So we're going to place all our x's with 4, right? So h prime of 4 is going to be f prime of g of 4 here is 2 times g prime of 4 is negative 2. And there's another level here. I need to find f prime of 2. F prime of 2 is negative 1. So it's going to be negative 1 times negative 2. So the derivative of part 5 at 4 is going to be 2. And there's how that goes. All right, I hope this is helpful. Good luck.